right, please be quiet. So on this page, what we're starting with today is we're starting our graphing unit. So the first part of our graphing unit is talking about relations. And relations are the beginning of functions. It's basically what all graphs are called. And today we're going to talk about specific characteristics with relations. So in the middle, I want you to write the word relations because this is our vocab word for today. I'm sorry, are you not entertained? I can represent a relation in multiple ways. If you keep doing that, I'm going to take off points. What is your question? What is your... You said something. You raised your hands in the air and said something. Okay. Alright, so the definition. A relation is a set of pairs. Hey, do you really want to keep interrupting me? Okay. Of input and output values. So we're starting our graphing unit. What is an input value on a graph?
It's what goes in the graph. The y-axis.
The input is the...
information.
Oh my god. It's the X. And what's the output?
Y, obviously.
Take a point, Aldo.
Yeah.
So input is X, output is Y. And a relation is a set of ordered pairs. So we're going to talk about 4 specific ways that we're going to represent a relation today, but we're going to list 6 over here that we can do. Are you guys ready?
Yeah.
Do you need an eraser?
Okay.
Oh. So those are the 6 ways to represent a relation. Our goal today is to be able to represent it multiple ways, so we're going to pick 4. We're going to do the first 4, and they're really easy because we can't create equations yet, and soon we'll be able to do that and write it in a sentence. Are we ready? Thank you for letting me know what I can and can't do. Well, we're going to do an example first, then we'll do a non-example. Okay, so an example of a set of ordered pairs would look like this. You would write a squiggy. Then you would write some points. So like 2, 5, 3, 7, -1, 8. That is a relation. Now what if I wanted to turn that into a table? What would go on the left side of my table?
The X.
And what goes on the right?
The Y.
Okay, what's my first X value?
2.
And what's the Y that goes with it?
5.
What's my next X value?
3.
And the Y that goes with it?
7.
And -1 and 8. Does it matter what order I put it in? It doesn't matter what order you put the X's in, but you do have to match up your X and your Y. Otherwise, it's chaos and doesn't make sense. Now, a non-example would look like this. What is that? And it's, thank you, it's called a variable. Take a point if you said variable. That is not a relation. What is this called?
Number. A coefficient.
Constant. Take a point. And what if I wrote for X? It starts with a T.
Variable and a number. Wait, stop there. Write another letter. Terminal.
It's a term. A terminal is... I can't with y'all anymore.
What's a term? Like, is it like the Modern Warfare 2 that? Hey, yeah, I played Modern Warfare 2. He's not wrong. That was the thing. That was the
Okay, so now that we don't know what a terminal is, we're going to go back in time and pray to all the gods that you take some kind of vocab class. We're going to go to 20B, and we're going to represent a relation in multiple ways. Now, there are 4 specific ways that we're going to do first. The first one that we're going to talk about are ordered pairs. Then we're going to talk about an input, output table. Then we're going to talk about what it looks like when we graph. And the final one that we're going to discuss is a mapping diagram. Yes. They made me chuckle. This is why we can't have nice things. Alright, so let's open this. We're going to write some words on the left, and we're going to do an example on the inside. Does everybody understand? Can anybody describe for me what they think an ordered pair is?
Two numbers that are two variables or two coefficients.
Thank you to those of you that raised your hands and didn't just scream out, but since everyone screamed it out for us anyway, we write sets of ordered pairs in the squiggies.
Yeah.
I drew a picture, geniuses. SQUIGGIS. Boom, squiggy.
She was a spelling bee
With commas, COMMAS. Commas have two M's, not one. That's a comma. They're two different things. Okay?
That's when you like die partially, right?
Yes, baby. When you die partially. It's not when you...
Because like your brain's still active, but it's not all.
That's not a coma. It's not Inception. Oh my gosh. Alright guys. Ordered pairs always start with which letter? And then? Fantastic. So what we're going to do is we're going to write a set of ordered pairs that is going to represent our relation, and we're going to turn that into an input-output table. We're going to graph it and a mapping diagram. Are you ready? He's talking to you, Rosalinda.
I said,
I would rather you not say that to anyone. No. 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 Alright, so then, write squiggy. You always start with an open bracket. And then we're going to write -3, 5. That's our first ordered pair. Please don't slam the tower. It's okay. 6, 2 is our next one. 4, -5. And our last one is going to be -2, -6. So we're going to take that set of ordered pairs and we're going to turn it into an input-output table. We're going to graph it and we're going to do a mapping diagram. And hopefully we'll actually finish so that we can talk about our bottom little chart that's the domain and range.
Wait, what is this? Dick's boy.
We hear you.
He asked her.
Alright, input-output table. Open this. We're done with the ordered pair. That's all you gotta do. So if I gave you a table first, could you turn it into an ordered pair? Look at us go. Alright, so on an input-output table, the input is X. The output is Y. And we have two kinds of tables that we can write. We can write a horizontal table or a vertical table. On a vertical table, vertical is which way? Up and down. Your vertical is how high you can jump. You don't hop side to side. You hop side to side. You don't jump side to side. Alright, so on a vertical table, X is on the left. Which way is horizontal?
Right.
Right to left. Whichever way.
You get it, miss.
For a horizontal table, X is on top. How are you confused? So what we're going to do is we're going to take these ordered pairs and we're going to turn it into both of those tables. So let's start with a vertical table. What does -3 match up with?
-5.
And then 6,
2.
4,
-5.
-2.
-6.
Take a point.
No, we should get 8 points. He answered all of them.
No. All right, so that's what a vertical table looks like. Here's what a horizontal table looks like. You do the same thing, except you write -3 and then 5, 6, 2, 4, -5, -2, -6. Yep, it's the same thing but sideways.
What's the point? Oh, it's the one before. Why not just do it one more?
Because I'm showing you all the ways that we can write a table. I don't have an answer to that question. Alright, when we graph, do we start with X or do we start with Y? And does X tell us to move left to right or up or down? Fantastic. Are you guys ready for the graphing part? And we plot X first, correct? Okay, so start with X. I'm sorry, are you not entertained?
I'm in.
No. Moves left to right, and then what does the Y do? Up and down. I don't know, but we're in math right now. Y'all ready to plot our points?
Not yet.
Okay.
I'm not ready. I actually put my thing upside down, so I had to erase it.
Fine, pumpkin. Alright, so let's start by plotting -3, 5. How do we get to -3, 5? Stop. Sam.
Take a point.
And then? Good. Take a point.
Good.
Jarrett, tell me how to get to 6, 2.
From the middle, and you want to count 6 spaces to the right. Yeah,
And then?
go up 2.
Great. Take a point. Jack, tell me how to get to 4, -5.
So you're going to start in the middle, and then you're going to go 4 to the right, and then you're going to go 5 down.
Good. Take a point. Logan, tell me how to get to -2, -6.
Go to the left one. You go down.
Take a point.
This is going to be our test.
No, do not connect the dots. Great question. Do not connect the dots. On relations, you do not connect the dots. Now, the last thing that we're going to talk about is a mapping diagram. Are we ready? Why?
We're always ready.
Yes, Pumpkin.
When you married, I think I asked you this. Do you like, when you're married, do you kiss your husband at the end?
We've already talked about this.
Yeah, I thought, I've never seen my mom go.
Alright, so you list your X and Y in order from least to greatest. So this time the order doesn't matter because we're going to do something fancy with this. List X and Y in order from least to greatest. So what's our smallest X? -3. And what's the next smallest?
-2.
And then?
4.
And then?
6.
Good. Take a point. Alright, what is our smallest Y? And then? And then? And then?
5.
Awesome. No. Also, if you have them multiple times, only list once. Only write once. Now, here's where the fanciness begins. You draw an arrow that matches them up. So from -3, we know it goes with 5. So we're going to draw an arrow from -3 to 5. It is. And what are we going to draw an arrow from -2 to? -6. What are we going to draw an arrow from 4 to? And 6? Boom. Okay, so you see how our ordered pair is -3, 5?
Yes.
So we're going to draw an arrow from -3 to 5.
Wait, but it's. Are they like dressed?
No. And do you see how our next ordered pair is 6, 2? So we're going to draw an arrow from 6 to 2. You do write at least to greatest. Yeah. Alright, last thing. Domain. Right here. So the D stands for domain. The I stands for input. And the X stands for the X coordinates. So when you list them in brackets. What are the X coordinates of this set of ordered pairs? Of this relation? Good. Take a point. That's all you have to do. Now, what would the R stand for? It's domain and range. So what would the R stand for? Hallelujah. The O would stand for output. And what would the Y stand for? Y coordinate. Sure. Alright, so what is the range of this relation? Good. Take a point. And that's all you have to do to list your range. It's just your Y values. Pardon? Yep. Have a great day. Make good choices. Be good people. Clean up your towers.